No. There's screen. Screen share. Okay. So we're gonna spend some time here looking at, I want to pull up your answer key first for your homework. So you can look at that. Make sure that you got everything right on that. If you didn't, ask me questions so we can go over these. So did you run out of time or did you not understand how to do them? Okay, so see if you got the first few right here and then figure out what questions you have about the ones down here. All right, any questions about the first few here? Yeah, question, Ernesto.
So, number 4 is when that NaNO.
Yep.
Wouldn't that be heat? Or wouldn't it be
Oh, yeah.
decomposition?
Yeah, it is decomposition. I don't know why I have single replacement down here. Yeah, that is decomposition there. Okay, anything else? So what questions do you guys have about these? Anything that you weren't able to get to work out right? Yeah.
I get double replacement and combustion except for what?
Well, combustion is always oxygen is a reactant. So some of these can be both. Like this one could be combustion. Well, I guess it is combustion. Yeah, this is a combustion one here. This one up here could be combustion or it could be synthesis. I mean, either one's right. They're both right. But anytime that oxygen is a reactant, that is a combustion reaction. So down here, combustion. Did that help at all?
Yeah.
Okay. All right, so I'm going to move on to the notes if you guys don't have questions. I'm going to start with these. We're going to talk more specifically about these single replacement reactions, and you have your orange sheet there. That is going to become like your Bible for this unit, okay? Because it's going to tell you in here what is going to form when you have these reactions. So we're going to start with synthesis. We're going to do synthesis and decomposition today. And then tomorrow, your A day people will have the day off because it's going to be just a catch-up day for B people. And then Friday, I will post a video on how to do single replacement and combustion, and you'll be responsible for that on your own using the video. So we've got an element here, and we've got another element. They come together to make a new compound. We also have some special situations where we would have an element and oxygen. That's going to form an oxide. This is all written on your orange sheet. You've got a metallic oxide and water. That's going to form a metallic hydroxide. A non-metallic oxide and water is going to form an acid. And remember, all acids start with H. And then some metallic oxides are going to join together with a non-metallic oxide and form a salt. All right, so let's do some practice with these. So I have barium here. Remember, barium is not a Brinkelhoff, so when it's by itself, it's not going to get a 2 down here. And then I have oxygen, which is a Brinkelhoff, so it's going to be O2. We're going to bring those two things together then. Now, here is the biggest mistake that people make in this unit, okay? The biggest mistake that they make is that they go over to this side to get their subscripts. You cannot do that, okay? When you bring these together, you have to look at your periodic table and figure out what their subscripts look like from there. You bring your barium and your oxygen together. This is a +2, this is a -2. So this thing is already done. Don't bring that oxygen over here and write that 2. Do not do that. Then you need to get this thing to balance, okay? Now, you can use your training wheels that I've taught you, but if you're getting comfortable with it, you don't need to. So barium, I've got 1 barium over here. Oxygen, I have 2, but over here I've only got 1. So I'm going to put a 2 out front here. That's going to give me 2 oxygen and 2 barium. So then I pop back over here and put a 2 there, and that gets my barium to balance. Good? All right. The next one is copper 1 oxide and water. This is a +1. This is a -2. I know this is a +1 because they told me right here. This I know is a -2 because I looked on my periodic table. Or by now you probably have that one memorized. That means that I'm going to need 2 of these for every one of these to get this compound to be neutral. And then I hope by now you guys know your formula for water. If you don't, it is on your orange sheet. Now we have to find on our sheet, on our orange sheet, what example this is. Well, this is a metal oxide and water. So this is going to be my example. I'm in synthesis, which is Roman numeral 1. And this would be Roman numeral 1b that I'm going to use as my example. And it tells me on my orange sheet that I'm going to form a metallic hydroxide. So my metal over here is my copper. They told us in our beginning that that copper was a +1. And then I've got, it says a hydroxide. Remember, that's on the back of your periodic table. That's a polyatomic ion. If you look there, you see that that is a -1 for its oxidation number. So this is balanced. Again, I don't look on this side for my subscripts over here. I have to bring the stuff together and go back and look and see what those subscripts should be. Fair enough? And I cannot emphasize that enough. That is the biggest #1 mistake that people make in this unit. All right, I need to get this to balance. So if I do my inventory, I have my copper, I have my oxygen, and I have my hydrogen. I have to break, I can't keep this as HOH here because there's oxygen over here, and that wouldn't work. So again, keep them in the same order. I have 2 over here. My oxygens, I have 1 here plus 1 here gives me 2. And my hydrogens, I have 2. Over here, everything is at a 1. So if I put a 2 here, that'll get everything on this side to balance out. And then I'm done balancing. Good? All right, next one. See if you can do the next one on your own. It's done like the first one was, where we're just taking 2 elements and bringing them together. So see if you can do that one on your own while I get all of this stuff erased. And clear some space to work here. Oops, no, that's not right. That's not right. That's not right. Don't look. Don't look. There. That's better. All right. I have cesium here. I've got one on this side. Nitrogen, I have two. Why do I have two here? Because nitrogen, when it's by itself, it's a Brinkelhoff. We have to have this two down here. Cesium is not a Brinkelhoff, so there's no two down. I bring these together. I look at my, I don't look over here. I look at my periodic table. This is a +1. This is a -3. So I have to have 3 +1s to get this to balance out. So I have 3 of these and 1 of these. Now, when I was doing this, I said even and odd, double the odd. So I'm going to put a 2 here. That gives me 2 nitrogen, but it gives me 6 cesium. So then if I pop back to this side, if I put a 6 here, now I've got this guy to balance. Everybody cool with that? Okay. Now I've got these. See if you can do these. I'll give you a couple minutes to work on those on your own. No, I just didn't give you room to do it. You can take out a sheet of paper. I can get you a sheet of paper if you want. That makes it easier. I don't know. I try every time to get this stuff to look right, and I always forget something. Okay. Oh, you want a new periodic table? Yeah. There's always extras up here in Esco.
Oh, really?
If you ever, yeah. Okay, so if you ever forget, that's where you're at. Yeah.
Where are all the different
Brinkelhoff's right there.
Oh, yeah.
Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine.
Oh, yeah, you just got a cheat sheet, right?
There's another one over here. And there's another one on your periodic table.
Oh,
And then hydrogen. Okay, that's not right. Got 2 here and 1 there. You have 2 of these for one of those. Get this though. That's a +2, that's a -1. That formula's not right.
Oh.
+2, -1.
You think it's doable too?
Well, don't take it from this side. It is a 2 because this was a +2, so you're gonna have 2 of these for every one of those. But don't look over here for those subscripts. Don't do it. That's a Brinkelhoff.
Oh,
It's a 2. Okay, and this has to have a parentheses around the graphs. And parentheses there. And that might be this. Yeah, that the 2 has to apply local polyton plan. The way you have it written, before you only had 1 oxygen and 2 hydrogen, so that'd be 1.
This is equals to, and this is minus 1.
Right, the whole thing is minus 1.
Yes, I got you.
This needs to have a 2 down here. It has to be a by that. And the reason why is because this is a plus 2. This is a minus 1. You have to have 2 minus 1s for every plus 2. Okay, they're balanced. So this isn't balanced. Over here you've got 6 fluorines. Over here you've only got 3.
Oh, right, that's right. Okay.
No, it's already balanced. Yep. Sometimes they're already balanced, and life is good. Everybody's got that one done. I'll do the first one then. I think everybody's got it up there right now. Barium plus iodine. Remember, iodine's a Brinkelhoff. Ba(I)2, because this is a plus 2, this is a minus 1. And so that guy's already balanced, just by chance. One done?
Yeah, but if you
Aluminum and fluoride. Oh, that, yeah, that's the third one. And then, oh, this is not, let's fix this, okay? So you would write it like this. This is where we had those parentheses. Like that, okay?
Yeah.
That makes me happier. Okay, so that's gonna form what? So we have a metallic oxide and water. It forms a what? Okay, so where your metal is magnesium, so it's going to make magnesium hydroxide on this side. Yeah. Yep, absolutely. Yep, and then you got to get the balance. All right, so then this one is magnesium oxide plus water is going to form magnesium hydroxide. Your hydroxide has to be in parentheses. And then this guy happens to already be balanced as well, just by luck. Remember, fluorine is a Brinkelhoff. Excuse me. So when it's by itself, we have to have the 2 down here. Aluminum is not, so no subscript for that guy. Bring it together. We're going to make aluminum fluoride. This is a plus 3. This is a minus 1. So we have to have a 3 down here. And we need to get this to balance. I have 1 aluminum. I have 2 fluorine. Over here, I have 1 aluminum. And I have 3 fluorine. Even and odd, double the odd. So I'm going to put a 2 here. That brings my aluminum up to 2 and my fluorine up to 6. So if I go back here, I put a 2 here for my aluminum. I put a 3 here for my fluorine, and that gets me up to 6, and I'm balanced. Okay? All right. So let's look at double replacement then, or just decomposition, excuse me, decomposition. All right, decomposition is the easiest one to identify because we have one thing and one thing only as our reactant. So if we only have one thing, it has to be decomposition because there's nothing to synthesize with it and there's nothing to replace in it. So it has to be decomp. And we have different situations here. And if you look on your sheet, your kind of cheat sheet that I gave you, you can see that we have one item coming out into two. Then we have special cases where we have like water, for example. Okay, remember these are both Brinkelhoffs. And then we have examples where we have polyatomic ions. So if we had a metallic chlorate, it's going to form into a metallic chloride and oxygen. Now this sheet, this orange sheet that I've given you, so the information that's on these 3 slides here, that will always be provided for you in class for any test or quiz that you might have on this material. So you don't have to memorize this. You just need to know how to use it as a tool, just like your periodic table. I didn't make you memorize that. You use it as a tool. All right. So metallic decomposition of metallic chloride, it goes into a metallic chloride and oxygen. If we have decomposition of metallic carbonate, it's going to form into a metallic oxide and CO2 gas. Decomposition of metallic hydroxide is calcium hydroxide is going to form into an oxide and water. So this would be calcium oxide and water. Decomposition of an acid, we're going to form into CO2 or non-metallic oxide and water. And then we're going to do some examples here. So my first example is strontium chlorate. Strontium chlorate is SrClO3, 2. That's how we write strontium chlorate. Again, if there's nothing else over here in the reactant side, it has to be decomposition. So I'm going to look on my sheet. For my sheet, this is Roman numeral number 2, which is all decomposition. And this is a chlorate. So this would be letter C on your orange sheet. So Roman numeral 2C, it says that we're going to form into a metallic chloride. So my metal here in this case is strontium. So strontium chloride. Again, don't look over here for your subscripts. This is a +2. This is a -1. So I've got to have 2 of these for every one of these to get this to balance out. It also forms oxygen gas. And then I need to balance this. So SrClO. Over here, I have 1 strontium. I have 2 times 1 is 2 chlorine. And 2 times 3 is 6 oxygen. Over here, I have 1 strontium. I have 2 chlorine. And I have 2 oxygen. So the only thing that's not balanced right now is my oxygen. So if I change this, if I want to change this to a 6, all I have to do is put a 3 here, and I've got it to balance. All right, next one is barium carbonate. Barium is a +2. Carbonate is a -2. So this guy is already, we don't need to change any subscripts for him. I'm going to find this one on my sheet. This is Roman numeral 2, which is all decomposition. And this is example D. And example D says that I'm going to form a metallic oxide and CO2 gas. My metal then is barium. So I'm going to form barium oxide. And I'm going to form CO2 gas. This is a +2. This is a -2. Do not look over here for your subscripts. If we look at this, I have 1 barium here and 1 here. My carbon, I have 1 and 1. My oxygen, I have 3 over here. Here I have 1 + 2 is 3. So this is already balanced. cesium hydroxide. This is a metallic hydroxide. This is Roman numeral 2E. So cesium hydroxide is written like this. This is a +1. This is a -1. So we're good with we don't need to change anything for subscripts. It says that it's going to form a metallic oxide. So my metal is cesium, and it's forming cesium oxide. This is a +1. This is a -2. So how many cesium am I going to need to get this to balance out? 2. Yeah. And it also forms H2O. So do my little inventory down here. I've got my cesium, my oxygen, and my hydrogen. On this side, I've got one of each. Over here, I have 2 cesium. I have 2 oxygen because 1 + 1 is 2. And my hydrogen, I also have 2. So all I need to do is come back here, put a 2 in front of here, and that gets the whole thing to balance out. All right? So now you take your turn at trying to do some of these. Huh?
Oh, sorry,
And 9-4 is your homework tonight. So if we run up to the bell, and I'll get the answers up there. 9-4 is your homework. Remember, lithium is a -2, or carbonate is a -2. Yeah, so it's a -2. So, and this is a +1. There you go. Yep, perfect. Okay. And then that's going to be this example. So it's going to form a metallic oxide. Your oxidation over some human oxygen. That's not written right. No. Lithium is a -1 or a +1. Oxygen's a -2. There. Okay. Much here. So lithium is a +1. This is a -2.
Oh, so you need to.
Yep. There you go. If you can't get these things to balance, if you keep trying to balance and it's not working, you probably wrote something wrong. Okay? Okay, so this is this is lithium carbonate.
Oh,
You have chlorine.
Yeah.
Okay.